LeetCode problem number 40, combination sum 2. So this problem gives us a collection of candidate numbers and a target number target. So our goal is to find all the unique combinations in candidates where the candidate numbers sum up to target. Each number in a candidate may only be used once, so this is quite a big clue. And the solution set must not contain duplicate combinations. So what this means is that, for example here, 116, so we cannot have something like 611, right? Where it's technically the same thing. Okay, so my approach to this problem is quite similar to the problem I solved for subsets 2, where I use backtracking and recursion. So here you can see I have a 2D vector here called the result, and then I have a one-dimensional vector called current. So here, I first sort the candidates. So let's say my candidate now is 25212, right? The examples given. So if this were to be sorted, it will be 1, 2, 2, 2, 5. And then when the recursion function is first called, okay, let me prepare a bit first. So result is a empty vector, and current is also an empty vector for now, right? And current is the one we are going to be pushing into our result, and result is the one that we are going to be returning. So at first call, the index is 0 and the target is 0 as well. No, sorry, the target is 5. So when the target reaches 0, since it's not, so we can just ignore this, but we have to enter this for loop. So I is equals to index, which is 0. And this we check for duplicate numbers, but since right now I and index are the same, so we can skip this. We can skip this as well because target is more than the current number, right? Our target is 5 and current number is 1, so we can just skip that. So we push back candidate I, which is 1, into our current. So we push this, and then we recurse. So when we recurse, it looks like this. Index will now become I plus 1, 0, 0 plus 1 is 1. Our target is target minus candidate I, so target is equals to 5 minus 1, which is 4. Since we do not reach the target of 0, we don't need to do anything, but our I will need to be updated to 1 now. Okay, then we enter the for loop again. This we can skip. This we can skip. Push back I1. I1 is 2. So current pushback is 2. And then recursion again. Index equals to I plus 1, which is 2. Target is equals to, wait, no. Yeah, target is equals to 4 minus candidate I, which is 2. So our target is now 2. And then once we're done with that, we recurse. So index is now equals to 2. I, this I equals to 2, so index is equals to 2 plus 1, which is 3. Our target is still not 0, so we enter again. Target now goes to, sorry, we have to push back first, right? We push back another 2 before we enter this recursion. Let me just backtrack a bit. So we push back this another 2, and then, so again, our index is 2 plus 1, which is 3, and our target is now equals to target minus candidate. So target, remember it was 2, 2 minus candidate I, which is 2, and now target reaches 0. So when this happens, we push back our current into our result, and then return. After that, once we're done with that, we pop back, and then we increment I. So I is now 3. Okay, so if you pay attention here, I is more than index, and now I, 3, and the number before it, so 0, 1, 2, 3, so this number and the number before it are the same, right? So what we do is we just skip and we just increment again. The reason for this is because we have already explored when the candidate I is equals to 2, so we do not need to revisit it, right? So when we increment from 3 to 4, we check again. Since 4, 0, 1, 2, 3, 4 is number 5, is not the same as its previous number, but the target is smaller than 5, right? And since at the beginning, since we sorted it, we know all the numbers behind this 5, but in this case, since 5 is the last number, but let's say if there were more numbers, we know the numbers before it are going to be larger than 5, which is more than what we need, so we can just return it. We can just return and break out of this recursion, right? Once this is done, we exit from here, we pop back again, oops, that's not popping back, yeah, pop back here, pop back again, and then we iterate I plus 1 to 2, and since both of these are the same number, so we just continue, same for this as well, continue, I equals to 4, and since phi is the same, right, so 5 is larger, our target is smaller than 5, so we just I plus plus again. So now, since we have finished this for loop as well, we exit here, and we pop back to 2. So once that is done, we check, since 2 and 1 are not the same, and our target is bigger than 2, I is equals to 1 from the increment. Then we push back 2, it's already been pushed back into our current, and then we begin the recursion again. Right. So this will continue on until we've practically tried every option. You just go through it some more. Index equals to I plus 1, so it's 2. Target is equals to 5 minus 2, which is 3. I is equals to 2, and then recursion. Under here again, index equals to 2 plus 1, 3. Target is equals to, remember just now, prior to that we should have pushed back here, and our target is now 2, 2, 1, right? So 2 from here, 2 from here, right? So our target is now 1. We are looking for 1 only. But since starting from index 3, 0, 1, 2, 3, all the numbers after it are more than 1, so we break. So you break out of this, eventually we break out of this as well. Since 1 until 3 are the same numbers, so we know from I equals to 1 to I equals to 3, they're all the same results, meaning that 2 plus any numbers that starts with a 2 in our current candidates, we have no solution, right? Then once we reach to candidate number 4, where there's a solo candidate number 5, once we reach that, push back 5, recurse. So because the point of recursing is we'll access this if statement where we will push 5 inside, and then once that's done, we return, we exit here, and then by right we will need to pop back, even though indicate at the end, but we will still need to pop back. That's the art of backtracking. So we have reached our initial state. We exit this for loop, exit this entire recursion function from here, and then we return our result, which is 1, 2, 2, and 5. So you see here, the answers are the same. Alright, hopefully this is a straightforward question, straightforward answer, and my explanation was straightforward as well. That's all I have to show. Thanks.